Assalamualaikum and hi. So today in this video, we will present about final year project for group KA25. The title is Comparison between Original and Stabilized Soil that affect shear strength characteristic. First and foremost, I would like to introduce our supervisor, Madam NOORAIIN, our group members, UMAR, FADHLI, and ILMAN.
Hi and Assalamualaikum. My name is MUHAMAD and I would like to present about our introduction. Firstly, peat is a type of soil with high organic content, high natural water content, high compressibility and low shear strength. Second, clay is a natural material composed of fine grained material and consists of tiny particles that have plastic and adhesive properties. Third, bearing capacity is important because it is the ability of soil to withstand weight applied to the ground above it. Last but not least, study about shear strength characteristic for different types of soil. First, non-stabilized soil and stabilized soil. Okay, next, I want to present about our problem statement. Firstly, peat and clay classified as problematic soil can causes bearing capacity failure, such as landslide. The landslides are happen due to the low shear strength of the soil, especially in the rainy season. And lastly, clay and peat have low shear strength, make them easily to lose and move as well as flow to other places. Okay, now I want to explain about our aims and objective of research. Okay, firstly, we want to identify the shear strength of original and stabilized peat and clay. Second, to know the workability of peat soils and clays stabilizer with polymer. And lastly, to compare the shear strength characteristic of two different types of soil. Okay, next I want to explain about our soil sampling. Clay sample was taken at Pagu, Johor, while the peat sample was taken at Parit Nipa, Batu Pahat, Johor. During sampling, trowels and container are used to conduct the test. Next figure show a sample of clay and peat placed in airtight container before being used for the direct shear test. In our research, we use disturbed soil. As you can see, there are two types of soil. Firstly, clay. The observation that we can see from clay, it is dark grey color, absorbing water slowly, dry slowly, clumps together and tough to break. While peat, the observation that we can see consists of particularly decomposed organic matter such as fibers, high water content, dark brown color, and lastly contain a lot of relatively loose organic coarse particles.
Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad FADHLI bin Muhammad HALUWI. My matric number AA200182. Next, we continue to sample preparation. After measure content of soil reach the range of 55 to 60%, a sample been waiting before insertion and in a 16 times 16 mm mold. Next figure show a sample of clay and peat being weighted. The VAC must be diluted first with water in a 1/3 ratio. That's 1 polymer 3 water. By using formula, mix the VAC with the clay and peat sample. From the observation, it was found that VAC peat mixed well while VAC clay was too weak. Therefore, VAC clay was cured for a week before being formed. Sample formation. Sampling formation is the process of performing a sample before a test is performed. However, for the formation of the sample, we provide sample with different day periods in 40 days before being started with direct measuring test. The table showed the period time of all the sample. The weighted sample is compacted by making a circle shape, then form the sample into the more size of 16 times 16 mm. Cure the sample using the shear mold to obtain the shape of the mold before the shear test is performed. Soil sample that has been compacted, removed and weighted before being left for 14 days. After 14 days, sample that has been reached the strength can be tested with direct shear strength test. That figure show a sample left for 14 days before testing. Direct shear strength test procedure. First, the sample need to be attached the two half of the shear box with locking pin and place the base plate at the bottom. Above the bottom plate, place the porous stone and above it place the grid plate. Second, for the base plate, place the porous stone and grid plate in the shear box. Weight the box at this stage and not down. Third, after that, place the soil specimen above the grid plate. Next, above the soil specimen, place the upper grid plate, porous stone and loading pad one above the other. Next, now the whole box is placed in a container and mounted on the load frame. Thus, proving ring is arranged in such a way that it should contact the upper half of the shear box.
Okay, for the first finding is moisture content. So here I show you two figures. First figure is moisture content reduction for P and second is moisture content reduction for clay. So we can see here, clay took almost about 7 to 8 hours and peat took almost 9 to 12 hours to achieve the ideal percentage, which is 55 to 60% of moisture content. Second finding is frictional angle. So we can see here we have two graphs. So both graph is the comparison in peak and residual strength that obtained in the direct shear apparatus on the original peat, original clay, the polymerized clay and also peat. So we can see that the stabilized soil have the higher shear strength than the original soil. In the table below, we can see the cohesion and also the friction angle of the sample. Friction angle is physical representative of the particle interlocking. The higher friction angle, the more tightly the particles are interlocked. So we can see that the stabilized soil have the higher friction angle than the original soil. That means the stabilized soil have more tightly particle interlocked in structure. Lastly, shear strength. So here we also have two graphs. The first graph is the stress-strain relationship of the original peat and also the peat polymer. And the second, stress-strain relationship of original clay and clay polymer. We can see that the stabilized soil have higher shear stress and higher shear strength better than the original soil.
In conclusion, the study showed that mixing clay and peat with VAC polymer can help overcome the problem of landslides. This is due to the study findings, which is show that after clay and peat were mixed together using VAC, their shear strength increased. However, in terms of friction angle, clay combined better with VAC than peat. As a result, the study will understand the shear strength characteristic of clay and peat before and after stabilization with polymers.